Good morning. Today we're going to be taking a look at what it takes to actually work with a foreign key and talk about the design and structures that go into that for using it with a database. So a foreign key is a way we can refer to information in databases so they can go across different tables, because a single flat table structure just really doesn't cut it for talking about how to actually work with information. So when we have our tables, after we've normalized them, we've got some information, we have a couple different tables we're always going to have, and when we have a foreign key, what we're doing is we're creating a reference so we can talk to another table, an entire row of that other table. So we have down here, we have our characters table, and as you can see right here, I've got 75 as the ID for Hermione, for the first name, and the universe is 1, 133 for a zombie head, and that's universe 3, and 999, first name is Cloud, universe 2. So what we have right here is this universe category right here, that column or that field is a foreign key. It's a reference to another table. And we're going to have that reference to that foreign table. It's going to go up here and talk to the universes table up here, and it uses that reference to the primary key of the universes table, in this case 1, 2, 3, 4, to talk about those. So we have Potter, Final Fantasy VII, Walking Dead, and West Wing, and they have a type of magic, sci-fi, horror, or political. So we have some information about that. And so by using this right here, when I go to 999 Cloud 2, I have access then to all the information that doesn't directly deal with Cloud as a character, but I can get the information about the Cloud universe right here from Final Fantasy VII Sci-Fi and any other fields that go along with that. Same thing right here with Hermione. I go to Universe 1, it's a Potterverse, and it's a magic thing, and I can have every other information that goes all attached to that as a information of that table as well, so I can get information across multiple tables. Now, when we're talking about foreign keys, we really want to talk about the way we actually structure them and how the way we work with them. And so the first thing we do when we're talking about our tables and stuff is we have to first get our tables put together. So we have our tables, and then we have to identify what the key is, or the primary key, what's going to refer to that, so we can use that information. And I use synthetic keys almost as a default because I like the way of having a generated value, something I can work with and use easily. And a number is really nice and easy to keep track of, and the name ID really easy to identify. When you're looking at a schema, or you're looking at existing code bases, the ID thing is really clear to click and understand. And so we first have the table. We then define the primary key. And I usually tend to define my primary keys after I define my table, so I can make sure I have, here's where I've got everything set up. I can make sure everything's logically put together. And then once my tables are put together, then I can create the relationships between them, and that's when I have my foreign keys that go along with that. And one of the reasons we want to have the foreign keys done secondary to the actual table creation, even though you can actually do them at the start, is when you're doing that design basis, when you're first putting together the structure, you may identify some component pieces and ideas to get after you get that done. And when you add a foreign key afterwards, you can make sure that all of your existing design specs are properly matched. So I like to have the basic design first, identify the keys, make sure that's all structured, safe, and good. And then afterwards, that's when I go ahead and I add in my foreign keys. And since I'm adding my foreign keys after I've actually put my structure together, I have everything ready to go, and I can identify the pieces immediately by looking at either my schema, my existing code base, or my notes that I've taken for that. So let's go ahead and take a look at the actual structure of what we need to do to make a foreign key happen inside the Squirrel language. Now, when we're talking about the Squirrel language, the first thing we have to do is when we're talking about making a change to a structure, we have to alter the structure. So using the DDL language, or data definition language, we're affecting the actual structure of the table, what we're creating for making that happen. So we alter, what are we altering? We're altering the table. So the table is what our first statement inside that, so we're altering a table to make that actual happen. What table we're going to alter? And we're going to alter our host names table. So the host table name is what I put on here. And again, I'm using my Squirrel naming convention and style convention, where I have all the commands left justified and all the fields new line and indented in. And even when I'm writing code on the board, I try and use that same process, so it's easy to identify what's going on. I also have the code, the keywords all in purple, all the all the keywords are in purple in caps, and all of the fields and component pieces are all in green, lowercase. Even if I have bad handwriting, it's all lowercase. Trust me, I promise it's all lowercase. And so we're using separated by underscore, aka snake case, to make sure we have that set up. So when we talk about that structure right here, the first thing we have to do, again, when we're making a change to the actual table, we have to do the alter table command using the DDL statement of alter table. We then give it the host table name. Now, again, when we're talking about our table names, we want to make sure that they're a plural or a collective name. But I use the host table name just as a sample right here because that's what we're talking about. And then the next thing we have is the add constraint structure. So the next piece we're going to do is we're going to add a constraint. When we add a constraint, we're naming what we're working with, and we're giving a rule for that relationship. So it's a constraint. It's something that's going to bind the actual structure to it. The naming convention for a constraint, it starts off with the prefix of FK. foreign key. Again, it's all lowercase. Then underscore. The first thing after the underscore is the external table name, the one we're not talking to directly right here in our alter table statement. So the other table. So other table first. So it's a foreign key from this table to this table. So foreign key, external table, host table. That's the structure we're looking with. And so whatever table you're working with, if I was working with over here on the characters name, I'm going to alter my characters table, so alter table characters, and then it's going to be a FK universes underscore characters for the foreign key structure I'm working with on that. I then have foreign key, so I'm specifying what I'm working with right here, so how am I altering the table? First, I added the constraint. The second thing is I'm naming a foreign key. So these are two separate pieces I'm putting together with that. The foreign key, it's important you put the foreign key inside the parens. The parens indicate what your key you're working with, and if you're working with a composite / compound key, aka one that has more than one single field, you'd separate these by commas inside the parens. So foreign key, parens, and identify the field name or field names separated by commas if you're working with a composite key. The next piece we're going to do is how we're going to talk to the other table. We do that with the references keyword. The references keyword in SQL says what table we're talking to. And then I go back to the external table. So again, right here, where that external table name up here in the constraint matches down here exactly. Now, if you're working with something, say, for example, like PHP admin, you'll often see this separated with backticks. Not required, but that's where that would be. Then we have in parens, we have our primary key of that foreign table. Because that external table, we need its primary key in the parens, whether it's a composite or a big one, a small one, whatever field. That's what's going to go inside the parens for that. So the foreign key on our table that we're working with starts off with the actual field that we're working identified inside this field, the not key, over here in this case, universe. The last piece we have when we're working with creating a foreign key is how we're going to maintain data integrity. And that's what the reference options happen. Now, there are a couple different options that exist. I'm only going to be using one of them. And the reference options are for the on-delete and on-update. The on-delete and on-update are both going to be set to cascade because I want my changes to be reflected down the line. So if I delete something, I want it to delete the associated components. If I update the thing, I want it to update the associated components. So whether I go good or bad down the line, I want to make sure that data integrity is maintained the entire way through. So again, when we take a look at the example that we had over here earlier, with the characters and the universes tables we're looking with, the characters table has a foreign key reference over here as the universe column inside this. So this table right here is the foreign key. So I'd be altering the characters table. I'm going to say that the universe field right here, this is going to be what we're working with. It's going to reference the universes table. And this foreign key identity value represents the primary key over here in the universes table, so I can get access to all that information that's not directly tied to the character, but the character needs to know that information. And that same approach works with every single type of foreign key. When we have a foreign key, it's a way that I can refer to another table's information that's not directly linked to this table's row entity idea or object or whatever you're looking at for understanding the concept. It's not directly part of this, but it needs that information to get a full thing. And especially after doing normalization, you will find yourself needing to combine those informations. And so when you're looking at doing something like a join or a multi-table select, you need that reference so I can get information from this table and that table. And the way we do that is by following that trail of the foreign keys so we can make that happen. One quick review again over the code that's necessary to make that happen. So we have the code to actually make a foreign key after the table itself has been made. We start with alter table. It's where we say, oh, I want to change the table, the DDL statement. I then specify what table I'm talking to. This is the host name, the table right here, in this case, universe we saw earlier. I then add a constraint for that. That's the binding, the name for it, so I can easily track it inside my own code, as well as see the references that exist for that so we can make that happen. And the foreign key constraint naming convention starts with FK, then underscore, the external table, the one that I'm not talking to right now, followed by an underscore and the table I'm actually in itself. So it's a foreign key from this table to this table for the setup on that. I then specify making a foreign key, and inside parens I specify the field that that foreign key is. In this case it was universe over here. Then I have the references keyword. The references keyword then specifies what table I'm talking to. In this case it's an external table name, followed by the parens, and inside the parens, the primary key, the key to the other table we're working with. The last part of when we're working with a foreign key, when we're creating this after the fact, is we have our data options and a reference options handle. The last thing we have after we do the alter table command statement that we're working with is the reference options, and what we do with that are the on delete and on update. And for both of mine in class, all the time we're setting those to cascade. The other options involve are null or restrict, but creating nulls, I don't like that. I never want to have bad data in my database. I try to have as clean data as possible. I don't want to introduce a null to it by default. And the other restrict, if I try to make a change, crash my thing, no! I don't want to introduce errors into my code. So my default structure when I'm working with this, my reference option is to do on update and on delete to both cascade, so those changes happen down the line. Now, of course, that does require actually planning my structure out, but we already know that. So the quick review, we had how to make the actual code to make that happen. We talked about the relationship of how that works across an example of using characters and universes. And then when we're designing the table, first thing we do, make the table. We then identify our primary keys. And then after we've got that structure put together, we can make those foreign keys happen because we have already got our structure existing. Thanks again and have a great day. We'll see some more database videos in the future. Bye.